All right, it's time to start our Unit 10 notebook. This is our last notebook of the year. Go ahead and type your name on slide 1 and we'll continue on. So let's learn about quadratic equations. Standard form. We should remember what this is. Standard form is when it's from highest degree to lowest degree. So for quadratic equations, it's going to be in the form ax squared, control greater than for this exponent button, ax squared plus bx plus c. So we have our quadratic term, our linear term, and then our constant term. The graph creates a U-shaped curve called a parabola. And if you see off to the side these shapes, that's what a parabola looks like. So you'll notice that you have one kind of pointing up and one pointing down. How do we know what the graph is going to look like? Well, it depends on what A is. If A, which is your leading coefficient, is positive, then the parabola will open up like a smile. So this is an example of a positive parabola. If the leading coefficient is positive, it's going to open up. It's positive, happy face. If your A value, again, the leading coefficient, is negative, then the parabola will open down like a frown. So if it's a negative leading coefficient, it's, negative emotion, frowny face. So let's take a look at these two examples. If my equation is 4x squared plus 2x minus 5, and I want to know if it opens up or down, I look at my leading coefficient, which is 4. So A is 4. More importantly, it's positive 4, so it's going to open up, which means it will be like this, somewhere on the coordinate plane. In this example, my equation is y equals negative x squared plus 7. The leading coefficient is this negative, which means it's really a negative 1. Got that invisible 1. And that means because it's negative, the graph will open down. You'll want to make that box bigger, and I'll drag this over here. Somewhere on that coordinate plane, it'll be opening down. The next thing we're going to learn about is the axis of symmetry. The axis of symmetry is basically what it sounds like. It's a line of symmetry. So if you think about back in elementary school, you did that art project where you painted a piece of paper and folded it in half to make it symmetrical, that's kind of what the axis of symmetry is. If you look at these two shapes, you could imagine folding it along a vertical line here and having it line up. And that line is the axis of symmetry. We can find the axis of symmetry by using the formula x equals negative b over 2a, where a and b are the numbers in the standard form. The axis of symmetry will always go through the vertex. Well, what's the vertex? The vertex is the highest or the lowest point on the curve. It's going to depend on which direction it's going. If the vertex is the lowest point on the graph, it is called a minimum because it's the minimum value. If the vertex is your highest point on the graph, we call that a maximum because it's the maximum value of the graph. Continuing on to the next slide. How do we use all that information to graph a quadratic equation? Well, the first thing you want to do is find your axis of symmetry. So find the axis of symmetry using that formula we just wrote on the last slide, x equals negative b over 2a. Step 2, find the vertex. And we're going to use that using the axis of symmetry. So we said on the last slide that the vertex is on the axis of symmetry, which means the x value is going to be whatever this is. So the point will be that negative b over 2a, and we're going to put that into the equation and figure out our y value. And we'll see what happens when we try an example there. Step 3, we're going to make a table of values with the vertex in the middle. So that means once we know what our vertex is, we want to do some points to the left of it, some smaller x values, and some points to the right of it with bigger x values. And once we have some points, usually we want 5 points, we're going to connect the points with a curve, which means it's going to be a U shape to form a parabola. Make sure you're not connecting the points with straight lines. It's got to be a smooth curve. Let's look at this first example. So the first thing I need to do in order to graph this parabola, this quadratic equation, is to figure out the axis of symmetry. To find my axis of symmetry, we're using that formula x equals negative b over 2a. So if I look at my form in standard form, a is the leading coefficient with your quadratic term. So here a would be a 1, b is negative 4, and c is positive 4. So that makes this negative 4 over 2 times 1. Negative 4 is just 4. 2 times 1 is 2. So x equals 2 is my axis of symmetry. I'm going to take that value of 2 and put that in the middle of my table because that value 2 is the vertex. What that means is at 2, that's my axis of symmetry. So if I fold the graph in half at the line x equals 2, which is a vertical line, think about Hoy-Vux, my parabola is going to be symmetric. So the vertex is somewhere on that line. I know x is 2, but how do I find the y value? I'm going to take that 2 and plug it into the equation. So I have y equals 2 squared minus 4 times 2 plus 4. And that's going to be 4 minus 8 plus 4. And 4 minus 8 is negative 4. Plus 4 is 0. So my vertex is at 2, 0, which means it's right here. A is what? 1. So if it is 1, would it open up or down? Well, it's positive, so it's going to have to open up. So I know my graph is going to look like that. But I want to know where the other points are, so I want to fill in some values to the left and the right of the vertex. So the next one I'm going to try is 3. All right, so I want to see what happens when x is 3. Again, all I have to do is take 3 and plug it into my equation. 3 squared minus 4 times 3 plus 4. That's 9 minus 12 plus 4. 9 minus 12 would be negative 3. Plus 4 is 1. How about 4? Well, if I put in a 4, 4 squared minus 4 times 4 plus 4, that's going to be 16 minus 16, which cancels out, plus 4, so I get 4. Let's do some to the left of the vertex. Let's do 1. If I put in a 1, I will have, let's see, 1 squared minus 4 times 1 plus 4. 1 minus 4 would be negative 3 plus 4 is 1. And how about 0? 0 squared minus 4 times 0 plus 4. So 0 minus 0 plus 4 is 4. Notice that this is symmetrical too. Because a parabola is symmetrical, we expect that if we're going the same distance, one value each time, that these are going to be the same. So 1 to the left and the right of the vertex gives us the same y value. 2 to the left and the right of the vertex gives us the same y value. Let's go ahead and fill this in on our slide. So I've gone ahead and filled in everything that I just found, my axis of symmetry, my vertex, the point 2, 0. Make sure you have parentheses so it's an ordered pair because it's a point. I filled out my table and I graphed my vertex of 2, 0. So I'm going to go ahead and graph the rest of the points at 1, 1 and 3, 1 and 0, 4 and 4, 4. And just get them as close as possible. And I'm going to use the opening up graph because I know it opens up and that lines up with all the points I got, so I know I've graphed it correctly. So let's figure out our axis of symmetry for this second example. First, I want to figure out what A, B, and C are. So A is my x squared coefficient, so A is -1/2. Which means I can already fill out this part. If it's -1/2, it would open down. So it's going to look like this. So it's my axis of symmetry. Let's figuring out B and C here. This one's weird because there's no x term, there's just this +5. So the 5 is the constant, so that means my C value is 5, but there's no x term. So if there's no x term here, how many x's are there? 0. So B is 0 because there's no middle term. So when I figure out my axis of symmetry, I'm doing -0, (b) over 2 times A, which is -1/2. And it doesn't even really matter what happens in the denominator. You end up with 0 over -1, but 0 divided by anything is 0. So my axis of symmetry is x equals 0. Also tells me that the vertex is at 0 something. That's my x value. Let's plug it in to find the y value. -1/2 times 0 squared plus 5. Well, that whole thing is going to be 0 plus 5. It's just going to equal 5. So my vertex is at 0, 5. Let's find some more points. Now this one, after I do x squared, I'm going to have to multiply it by 1/2. And I want to make sure, because it's a fraction, I don't want my answers to be fractions. I don't want to plot any points that are fractions because I won't be able to graph it accurately. So what kind of numbers do you think would be good to put in for x so that when I multiply it by 1/2, I won't end up with a fraction? Even numbers, right? Because if I square an even number, it'll still be even. And then if I divide an even number by 2, I won't get a fraction. I'll still have an integer. So instead of putting in a 1, I'm going to try 2 and 4. And on the other side, I will do -2 and -4. So let's see what happens for 2. I would have -1/2 times 2 squared plus 5. 2 squared is 4, and then half of 4 is 2, but it's negative. Plus 5 is 3. And because I know it's symmetrical, I should get the same for -2. Let's see what happens, which is still 3. How about for 4? -1/2 times 4 squared plus 5. 4 squared is 16. Half of 16 is 8, but it's negative, so it's -8 plus 5 is -3. And if this is -3, the same thing's going to happen if I put in a -4. I would still get 16, and then it's still -8. That's another -3. Let's go ahead and fill out the rest of our notebook for this one. So I've gone ahead and again filled this out with my axis of symmetry, vertex, and all my points. So I've got my vertex here, and this one's going down. So we've got our points at -2 and 3, and symmetrical across from that is +2 and 3. And then -4 is -3 down here, and +4 is also -3. So I'm going to use my opening down parabola. There you go. All right, my last example here. Want to note what A, B, and C are. A is going to be 2, B is 6, and C is -1. I'll go ahead and fill out that I know A is 2, which means it's going to open up. Let's find our axis of symmetry. Negative B, so -6 over 2A, 2 times 2. That's going to be -6 divided by 4, which reduces to a -3/2. So x is going to be a fraction this time, -3/2. So I will put that here. Unfortunately, we'll have to do a little bit of math with the fraction. If I want to find my vertex, I'll be putting -3/2 into this equation to get the y value. So 2 times -3/2 squared plus 6 times -3/2 minus 1. All right, so if I square this, we're going to get y equals, that's going to be a positive 9/4, because remember negative squares can be positive, and you square both the top and the bottom. So 9/4 times 2 is going to be the same as 9/2. I can cancel a factor of 2. 6 times -3/2, I can cancel the 2. And then I have 3 times -3, which is -9, minus 1. So that's going to be 9/2 minus 10, which is -11/2. If I want to pick the next point, I would like to use a number that's not a fraction anymore. So think about what integers this is between. So that's -3/2, that's -1/2. So what's the next closest integer to the left? That's going to be -2. And then if I go to the right to the next integer, that's -1. And then I can go by ones. This could be a 0, and that could be a -3. Let's find those values. So if I start with -1, 2 times -1 squared plus 6 times -1 minus 1. That's going to be 2 times 1 is 2, minus 6 minus 1. So that's -4 minus 1 more is -5. And I know since it's symmetrical, I would get the same answer for -2. How about 0? Well, at least that one's nice. 2 times 0 squared plus 6 times 0 minus 1, which is going to be 0 plus 0 minus 1. So I expect this to be -1. Let's just verify that. Hey, look, I did get the same answer. Let's go graph those. So the vertex is at -3.5, which is -1.5, and then 11/2. So -10/2 would be -5, -12/2 would be -6, so we're between -5 and -6, so about there. And then my other points, -2, -5, and -1, -5, so it's kind of close together since the points are so big. And then your next points are -3, -1, and 0, 1. And it's opening up. So we get something like that. That's it.